Okay, so today we're going to be working with. Let's go for it. Come on. Okay, so today we're working with. Thank goodness, not that we don't need a calculator. What's the calculator? Go away, calculator. Go away. Okay, so let's just calm down a bit. Calm down a bit. Okay, so we're working with identical items. Now, here's a whole nice formula, that, and I've given you a link to somebody else who explains really well how those formulae come about. And we're not going to go through the how in this video. Go for it, watch it, enjoy. It is interesting, but we're just going to apply it in these and see how it applies. So, they're there. Last one, you said that these bullet points didn't make sense by themselves and we needed to jump into the examples, so let's do just that. So how many different words are possible using the letters L-U-L-L-L? Now, it says words because there might not be, words that are in the dictionary, but they're still considered words. You don't need any formulae for this. Just write down how many different words are possible using those 4 letters where the L is repeated like that. Okay, well, I reckon there was one, lull. Lull's written there. Lull. Then maybe we could have had ululu. Okay, or we could have had, I guess we could have had L-L-U-L. Lull. Or hlul, maybe. And we could have had L-L-L-U. Lu. Lu. It's in the anyway. So, they're the 4 different options. Now, it didn't matter, if you thought that was the first L, the second L, and the third L, well, we could have had U-L-L-L, where each L was like, but I was in a different order, 3 was ahead of 2. We don't know that. We consider these 2 to be exactly the same. They're both U-L-L-L. U-L-L-L. And that's where this accommodation comes in. Okay, so let's use our formula to do this, because obviously our formula is going to help us when it's a bit more complicated than lull. Ready? Okay, I'm sure you are, so I love it. So here we are. So our formula says that what we need to do is, in our thing, n is the number of letters or the number of places there are. So there are 4 different places here, so we're going to put 4 factorial on the top. Then, to kind of compensate and make up for the fact that we've got repeated letters, we're going to say the L is repeated 3 times. So on the denominator, we're going to write 3 factorial. So basically, we're using this one over here. So you punch that into your calculator, and I wonder.
What do you get?
Okay, well, I hope you got 4, because I got 4 as well. Yay! Okay, so yay for 4. So, I hope they're 4, because we saw there were 4 there. Okay, let's do another one. So, how many different words? Now, I'm just going to say words, because doing that isn't that a bit annoying if it's like how many words? How many? Yeah, well, yeah. So, how many different ones are doing lulu? So, L-U-L-U. So, in this case, we could write down the different possibilities and we'd go, okay, well, we could have L-L-U-U, we could have L-U-L-U, and we could have L-U-U-L. And that would be if, we started with an L, but maybe we started with a U, and then we could have U-U-L-L, or we could have U-L-U-L, or we could have U-U-L-L. Those are the 6 I see. And, covered up by my head or not, there are 6 options. Okay, but let's use our formula to see how it gets there. So now we're going to use version 2 of the formula. This one over here. So this one says, now we're just remembering kind of how we work these things out. There are 4 different letters. So in our previous time, we kind of thought there were 4 different things to fill in. So we're going to put 4 factorial on the numerator. Now on the denominator, we're going to look at all the possible things that could be repeated. So there are 2 L's. So we're going to write 2 factorial. Then there are 2 U's. So we're going to multiply that by 2 factorial. Now you may ask, in the previous one, we didn't multiply by anything. Well, we sort of did, because in this case, there were 3 L's, which gave us our 3 factorial. But there was 1 U, so we could have multiplied this by 1 factorial. So if you really wanted to, you could say, well, we're applying the same formula. What is 1 factorial? Well, 1 factorial is just 1, so multiplying by 1 didn't really do too much. So in this case, we've got 4 things we need to fill in. 1, 2, 3, 4. We've got the L repeated twice. We've got the U repeated twice. So that's what we get. Into the calculator, and tell me you don't get 6 on the calculator. Well, I hope you get 6 on the calculator, because there are 6 over here, and that is 6 on the calculator. So there we go. Let's head into one more example in this video, and then maybe we'll break it up and do the next one in the next video. So consider the 7 notes: do, re, mi, fa, sol, la, ti. Determine how many 7-note tunes can be created if any note may be used once only. So this kind of makes us think of, we've got 7 different blocks, and I'm starting to think I may be a convert to 1, 2, 3, 4, 5, 6 to doing this with lines, not blocks, but we had it with blocks before. So we can only choose, if we put do in the first one, then we can't have it in any of the others. So this just makes us think, well, in the first one, we could put any of the 7 in, right? In the second one, 6. In the third one, we have 5 options left: 4, 3, 2. Once we've filled the first 6 blocks, well, we've only got 1 thing left to place in the last one. So what's a short way of writing 7 times 6 times 5 times 4 times 3 times 2 times 1? Well, 7 factorial, right? So that gives us 7 factorial. I'm just going to give it to you 5040. So this looks like an example we did previously. You're filling in seating people or notes. Okay, now let's, still got a lot of options. Now let's consider the same idea. We've still got our 7 things over here. 4, 5, 6, 7. Determine how many 7-note tunes may be created if a note may be used more than once. So we could have do, 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 do. So in this case, we've got 7 different options to put in here. How many options do we have to have in the second note? Well, we've also got 7, because we can repeat ourselves now. So we've got 7, 7, 7, 7. Come on, you're going to miss it, eh? So we've got 7, 7. In each of these, we could use any of our 7 notes over here. So therefore, we've got 7 times 7 times 7 times 7 times 7 times 7 times 7. And therefore, we've got 7 to the power of 7 equals some large number. I get 8, 2, 3, 5, 4, 3. Okay, 2 more within our do, re, mi, fa, sol, la, ti. And T, by the way, I think you can spell in multiple ways, but they've gone TI, yeah. Okay, so, and again, tunes. Do you think, some tunes weren't considered? If you're like, do, 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 soccer, do. See, that's the video with all the identicals at the beginning. Made me think of that video. Okay. Pause and breathe, I think. Or is that for me or for you? Okay, so notes may be repeated, but the tune must start and end with do. Feels like Homer Simpson around here. So we've got 1, 2, 3, 4, 5, 6, 7. In these first and last ones, we must have do and we must have do. So in other words, there's only one way of doing that one, and there's only one way of doing that. And we can fill in the rest as we like. So how many different notes could we put in that block over there? Well, any of the 7. Same for any of these. We could put any of the 7, any of the 7, any of the 7. So it could go do, 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 do. It could go do, re, 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 mi, fa, do. But in each of these, you could have any of the 7 notes. So therefore, we're just going to take those things and we're going to multiply them all together. And here we can see that we've got 7 to the power of 5. That doesn't really matter. The examples are always small enough that you could go 7 times 7 times 7 times 7 times 7. I think it's worthwhile just seeing that as 7 to the 5. So 16,807 different little jingly tunes. Okay, last one for this video. Consider the 7... again, we've been through that. So we've got our 7 notes. Now for this one, this is going to be a bit more interesting. So we've still got our 7 note thing. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. But now in this one, we must have 3 do's, 2 me's, and 2 so's. So now we go back to that formula that we're learning about today. And our formula is this one over here. Now I feel like the formula looks more complicated than it is. But if we know how to use it, then we're like, it doesn't seem too bad at all. So in our formula, this means that we're filling in a certain number. So we're filling in 7 notes. So we're going to put 7 factorial in the numerator. In our denominator, we are going to look at all our repeated options. So in this case, we've got 3 repeated do's. So we're going to have 3 factorial. Then we've got 2 repeated me's. So we're going to multiply by 2 factorial. And finally, we've got 2 so's, so we're gonna times by. I actually changed my mind there. We've got 2 so's, and so we got 2. So that's what each of these R's mean. Which bits are getting repeated, and then you could kind of think of the non-repeated things. But in this case, 3, 2, 2. That would fill our whole tune. So you just plug that into a calculator, and you know what? What do you get? Okay, well, I got 210 over there. And I remembered to put a smiley face. So that's what I get. So I think let's head back into it. But we've got to go back to this one.